Alright guys, so this is video 2 here. I'm not sure what happened to the last, I started recording this and something happened, so you're going to see that this is partially done already. So I'm going to walk through this with you. So I'm told that a boat leaves the entrance of a harbor, leaving at 4 knots for 15 minutes, at a bearing of north 42 degrees east. It then turns east at a speed of still 4 knots. After an hour, they want us to sketch the path of the boat. So we're breaking this down, guys. So he went at a bearing north 42 degrees east. So I went ahead and drew this coordinate grid. And he went north, east. And this is the 42 degrees right here. Okay. So I just drew this line right here. And then he turned due east. So at that point, he started going this way. Okay. So that's part A right here. I sketched the path of the boat. That's all you need to do. But what I went ahead and did is found the actual distance. Okay, and so since I'm dealing with knots, it's a little bit weird here. So here, a knot, guys, it told me I'm running for 15 minutes at this bearing. So after an hour, because that's what they told us here, he's traveling at 4 knots for 15 out of the 60 seconds, because that's 60 minutes. Excuse me, 60 minutes. 60 minutes is an hour. So when I simplify this, is equals 1 mile. So this distance is 1 mile. If I do the same after he turns, 4 knots for the remainder of the hour. So if he already took 15 minutes, 45 minutes is left. So 45 out of the 60. Once I simplify this, it equals 3 miles. Okay, and don't worry about this. You'll have a calculator to do this. So next is how far is the boat from the harbor entrance. So the distance they're actually talking about here, guys, this is the harbor entrance. This is where I started, the origin, the original origin, okay? And what I want to know is, what's this distance right here, okay? Oops, from here to there. So I'm going to draw a triangle over here, okay? Starting to draw one. Okay, so if I were to draw a triangle, what I just drew is this right here. I know that this total distance down here is 3 miles plus some distance here, x. Okay, so this is x and this is 3 miles. So over here, this is some x plus 3 miles. Okay. I know that this distance in the y direction right here, this is the same y distance here. I don't have to add anything. So this right here is y. So if I know x and y, I can solve for the rest of this here. Okay, so what I'm going to do here is break up this right here. So this little triangle here can tell me what is x and what is y. Okay, so doing that, okay, I'm going to draw a little triangle here. Okay, so if I say this is the angle theta, okay, which I know because right here, this piece was 42 degrees. That means the inside part over here is 48 degrees. So this angle right here that I'm talking about is 48 degrees. So if I label my triangle here, this is my O, this is my A. So I could solve for for A by, this is my H, sorry. A over H is equal to my x value. So cosine theta equals A over H. So cosine of 48 degrees equals x over 1. So if I multiply by 1, my x is equal to the cosine of 48. Sorry about that, guys. That's my dog. Okay. Okay. So when I plug this in the calculator, I find that this is 0.69. Okay. I'm going to do the same to solve for y. So here I'm going to use sine sine theta is equal to O over H. And pretty much the only thing that changes is that it's sine now. So sine is equal to my y value over 1. Okay, so I'll multiply by 1. So my y is equal to sine 48. I'm not putting the 1 because, I mean, you don't need to. So my y value is, after I plug in the calculator, 0.74. So if I look at my big triangle here, okay, I know that this is 0.74, and over here this is 0.69 plus 3, which is 3.69. Okay, so remember, I was looking for the distance from here to there, okay, from here to there. So this is my hypotenuse, okay, and so, excuse me, since I know this length and this length, I can solve for the hypotenuse using Pythagorean theorem. So I'm going to use a squared plus o squared, oops, equals h squared. Okay, so 3.69 squared plus 0.74 squared equals h squared. Oops. So h squared is equal to, excuse me. So once I solve for this, if I plug this in the calculator, I get that h is equal to 3.76. And this should be in miles. Okay. So next they're asking for the bearing. So they're asking for this right here, guys. Okay, this right here. So I can't necessarily find that just yet, but since I already know the sides here, this is my theta right here. Okay, so if I solved for theta, because I know O, I'm sorry, I should have wrote this over here, and I know A, okay, tangent theta is equal to O over A. Tangent theta is equal to O, which is 0.74, A, which is 3.69. So if I solve for theta, it is the inverse of these two, okay, of this ratio. So when I solve that, my theta ends up being 11.3 degrees. So that means this theta right here is 11.3 degrees. But that's not what I'm looking for. I'm looking for this right here. So remember, this is just 90 over here. This distance is 90 minus 11.3, which is 78.7. Okay. So if I want to do the bearing, guys, okay, so I already know that it's going to be 78.7. And first I had to go north, so north, and then I went east to get to that point. So this is the end of that right there, okay? So y'all were wondering who was barking. This is this girl right here.